So we're on page 11 of your chapter 2 packet. Okay. And we learned yesterday power rule, which is going to be a much more efficient way to find the derivative than with a limit definition. So we learned that if I have x to the nth power, you can find the derivative by simply bringing that exponent down in front and then subtracting 1 from that current exponent. Okay. I'll do an example for number 1 in a bit, but here are also some conditions. We have to make sure radicals kind of stand in a way. We have to get our radicals converted to rational exponents. So for instance, if I have square root of x, I need to convert that to x to the 1 over 2. And those numbers are coming from the fact that there's a hidden 1 to the right, and there's a hidden 2 being the square root. Denominator variables have to be brought up to the numerator before we can do power rule by making the exponent change signs. So if I have 3 over x to the 4th, I can't do power rule with the variable in the wrong place. We have to push this up to the top. We got to make it 3x to the negative 4 before we can apply power rule. Okay. And then the third condition, parentheses have to be resolved. So all terms have to be expanded. So if I have 3x squared plus 1 squared, I can't do power rule here until all the parentheses have been resolved. So I got to FOIL this out. Get all the parentheses to go away. And then we can do power rule. Okay. So let's start with the easy one here. Number 1, f of x equals 3x to the 5th minus 4x plus 156. Each of these terms, if we look, no radicals to worry about, no denominator variables, and it's okay to have denominator coefficients. We just don't want any denominator variables. And then there's no parentheses to resolve, so we're good. Okay, so now we want to find the derivative, which is going to be a slope formula for whatever this curve looks like. F prime equals, okay, Mario, I'll try this one here. What's 3x to the 5th going to turn into? Good. And then 4x, what's 4x going to turn into? Just 4. Just 4, right? So there's a hidden 1 here, right? And then once that 1 comes down, 1 times negative 4 is negative 4, and then we subtract 1 from the exponent. So 1 minus 1 is 0, so it's just going to be minus 4. Right? Does that make sense? And also another thing is, once you're down to this linear, you may not have to worry about using calculus, because you see how this is y equals mx plus b. So if it's in the form of y equals mx plus b, if it's just a linear expression, you know that the slope is always going to be the coefficient in front of the variable if it's to the first power. So here, negative 4x, same thing as y equals mx. So my slope is negative 4, and derivative is just slope. Okay. What about 156? Okay. So 156 is a constant. So think of a constant as a horizontal line. And what's the slope of a horizontal line? 0. So it just goes away. So we don't have to put a 0 there, but I just want to show that how each of these terms are impacted by the derivative. Okay, number 2. So we have to look at our conditions. What's the condition that we have to worry about for number 2? What's out of place? Denominator. So what would your guess be to how can we resolve this so that our problem can be applied with power rule? I think you have the right idea. You have the right idea. You definitely are trying to bring the denominator up, but is the 3 and the x to the 6, do they have to be, can they be separated? Do they have to be connected? So the idea is that now if it was a 3 plus x to the 6, that's a different story. 3 plus x to the 6, we can't easily separate. But 3 and x to the 6, they just happen to sit next to each other, but they don't have to be connected. So basically, we can just move the x and leave the 3 alone. So what would that look like if I were to just move the x and leave the 3 alone? Yeah. Okay. Good so far. Now, we want to find the derivative, but I think it helps visually if students don't have to look at a denominator numeric value. This is not an issue for power rule, but it just makes it look a little messy. So what I like to do is I like to push coefficients out in front so that I can clearly just deal with the x without having to stare at anything below the x. So this is what I mean. So I'm going to rewrite it as f of x equals 5/3 x to the -6. Okay, these mean the same thing, but just in general, students just tend to feel a little bit more comfortable with this because then that 3 is in front and doesn't mess with what you're doing with power rule. That makes sense. Okay, so now ready for power rule because all of our conditions have been met. So what's f prime going to look like? Yes, thank you, power rule.
You multiply, do the -6 times 30, times 5, and get 30, and then the -7.
Good, right. So -6 comes down. It comes down. That deals with it as a coefficient in front of the 5/3. And then once that -6 comes down, we take the time to finish the rest of the power rule, which is subtracting 1 from that initial exponent. Okay, we still have some cleanup to do, but any questions up to this point? Okay, so now I'm going to do a little bit of cleanup. The -6 and 5 can combine to be -30. I can also reduce -30 over 3 is -10. And then our final step, we have the derivative. So we're going to do a little bit of cleanup. We're going to reduce our fraction. And then we're also going to put the x in a better spot. We want positive exponent in our final answer. So right now the x is sitting in the numerator. We're going to force it to the denominator so that the sign for the exponent can change. Okay, so number 3. And again, the role of these derivatives is they are helping to describe how the slope is changing at every point for the original graph. Right? So we keep reminding us of that this derivative The whole purpose of this is to help us find the slope rate of change of this original function. Okay, number 3. G of x equals 3 square root of x to the 9th power. We want to do power rule. We want to find the derivative. What adjustments need to be made?
You have to get rid of the root.
Yeah, gotta get rid of the root. So how can I rewrite this?
3x to the 1.
That's what a lot of students do. I think that's the most common mistake that students make with with something like this. A lot of students want to say that it is x to the 1/9. It feels very natural, but this is not quite it. Okay, you put a star next to it because this is the most common mistake in terms of mistakes that students make with radicals. Anybody know what square root of x to the 9th is? 9 over, not 9 over 3, 9 over, now, okay, so the 3 is the coefficient, so don't worry about the 3 yet. We're just going to worry about that square root of x to the 9th. Not 9 over 1. Good. Right, so I think that's the troublesome thing is that we forget square root is a 2 there. Okay? And if you don't remember, I think a lot of students know that square root of x is x to the 1/2. So maybe you want to put this at the top of the page when you take your test or quiz is square root of x 1/2. The reason why it's x to the 1/2 is because there's a 1 hidden to the right and there's a 2 hidden to the left. And if you can have this as a model, then you can always use this to kind of help you figure out where the number is supposed to go. Right? So if I have a 9 here, no number here, there'll be 9 over 2. Okay, good so far? So I'm going to put that 3 back into the problem. So now we can do power rule, right? Everything is okay with the rest of the expression. No parentheses, no radicals, no denominator, variable. Okay, so G prime. Okay, what's the derivative here? We're now the 9/2, right? So once that 9/2 comes down in front, what needs to happen with that 9/2 up top? Subtract 1. What's 9/2 minus 1?
7/2.
Yeah, because common denominators, right? So if you want to put 2 over 2 as a reminder that there needs to be common denominators, 9/2 minus 2/2 would be 7/2. Yeah. Okay, good so far? Okay, we can push those, combine those coefficients together. We already are sitting at a positive exponent, so we don't have to move that exponent. Okay, questions so far? All right, number 4, any adjustment needs to be made? How would you rewrite this term?
One-third x to the 9/2.
Good, good. So let's deal with that numerator first. You know it's x to 9/2 over 3, right? And I like what you did. Can you talk about what you did with that 3? John. You said it. I just wanted you to.
I just did like 1/3 because when you move the variable out of the top part of the fraction.
Yeah, so that's what I prefer as well. That 3 kind of makes a little, just feels like it's in the way of what we want to do with power rule. So to make it a little cleaner, it doesn't change the problem. It just makes it visually easier. Let's push that 3 out in front, and that 3 is in the denominator, which is really, it's really a 1/3. So we haven't done any derivative yet. We just want to make it as clean and easy to look at when we're doing our power rule, before we do power rule. So these mean the same thing, but I think we prefer this a lot more than looking at this. Okay, so now power rule. Okay, bring down the 9/2. It'll eventually multiply with that 1/3, and then we can also subtract 1 from the exponent, just like how we did with the previous problem, right? Subtract 1, which is matching common denominator, so -2 over 2. Do a little bit of cleanup. 9 and 3 can reduce. We get 3/2. Okay, questions so far? Okay, number 5. What's in the way? Parentheses. Okay, so tell me how you would clean up those parentheses. 4t, not squared, but we have to raise everything to the 3rd power, right? So what would that be? At to the 3rd. Okay, let's do that. That at least gets rid of our parentheses. Okay, that's a good first step. At least we got rid of the parentheses, but we still have some thing to do to clean up, right? Okay, good. 40t to the 3rd. Anything else? Is that t to the 3rd okay for power rule? Okay, where does that t have to be? That's right, with the 7. So that's in the wrong place, right? That t variable is in the denominator. So what happens if we push it up to the top? What changes? Or what would it look like?
Turn to t to the 1/3.
Not t to the 1/3. Anybody else? Right. So anytime we want to change places with the variable between numerator and denominator, we're not going to flip the exponent. We're just going to change the sign of the exponent. Okay. Yeah. So. So 7t to the negative 3 over 40. Again, I think most students prefer not to stare at a number below the variable. So we're gonna push it out. Feel like as if it's in front. Let's make it a fraction sitting in front of the variable before we do power rule. You don't have to. It just seems a little cleaner that way. Okay, so now I do power rule, right? Bring that exponent down, multiply, subtract 1 from the exponent. Clean up, push all the coefficients together, and then we can finish off. We have the derivative, but we're going to clean up now by pushing that t back down to the denominator. Questions? That's right, yeah. So anytime I move a variable between numerator and denominator, I can just keep switching signs depending on where I want it. So initially I wanted it at the top so I can do power rule, but then once I'm done with my calculus, I'm going to bring it back down because I want my answer to be in terms of a positive exponent. Okay, guys, okay? All right, let's skip number 6. I think it's virtually the same. Sorry, it is the same problem. I didn't mean to put that there. So let's try number 7. Okay, what do you guys see here with 7? Anything out of place? Any adjustments that need to be made before we can do power rule? Okay. How about let's change the radical first? So how would you change it?
7 over x. And put x 1/2 to the side.
Mm-hmm.
Or would you make it negative? Like 7 to negative 1/2 since you're trying to move it to the numerator?
Mm-hmm. Yes, but before we do that though, there's actually a hidden parentheses going on here. We need these x's to be together. If we move the x's up to the top and there's an x and x below, that's an issue, right? Because this x has to move, but then this x has to move as well, right? We can't just move this x without moving this x. But these are pretty much the same thing, so why don't we just merge them together? So how do I combine the x and x to 1/2 together? So we have to deal with the exponents. There's a hidden exponent with this x, which is what? It's a 1. What do I do with those exponents to help combine these two terms together?
Denominator. So would be 2 over 2.
Yeah, that's right. I got to add, right? I have to add these two. I can't multiply. I got to add them. So 2 over 2 plus 1/2 is... What's 2 over 2 plus 1 over 2? 3/2. Okay, so now, so we took care of the radical. We pushed the two variables together, and now we can move it. Okay, now we can move it. So what does it look like after we move it? Seven what? So this is ready for power rule. Everything before is not. Everybody see that? Okay, so now I can do power rule, F prime. What's my new exponent going to be?
-5/5.
Because I'm subtracting 1 from the exponent, right? I'm just going to mash that denominator, -2/2. All right, clean up. Multiply the coefficients together. Push that variable back down to the denominator now that we're done with our calculus. Now we can get that negative exponent to show positive by moving it down. Okay, questions? All right, let's look at number 8. What's in the way of power rule? Yeah, radical in parentheses. So both of these have to be cleaned up before we can do anything with power rule. So what's 5 squared root of x? We got to deal with these parentheses too, right? We can distribute the negative 3x squared through. So what does that become? Okay. Right. So now all of our conditions have been met. No radicals, no denominator variable, and no parentheses. Okay. Now we can do power rule. What's my new exponent for my first term? Yeah, okay, good. 5/2 is coefficient, but what's my new exponent though? What does that 1/2 turn into?
-1/2.
Okay. -2/2, -1/2. Okay, keep going. Next term becomes to the what? Yeah, to the 1, we can leave it alone. Okay, plus there we go. We have our derivative. Now let's just do a little bit of cleanup here. Okay, next page. let's do number 11 first. Okay, 11. All right, what do you notice about 11?
Get rid of the radical.
That radical, right? That radical is two things, right? The radical is in the wrong form, and also it's in the wrong place. But the way that I like to approach these types of problems is, let's think of it as three separate fractions. Okay, if you think of it as three separate fractions, we can then treat them like individual problems, and we can handle each condition separately. Just makes it a little bit cleaner if we can just separate this into smaller problems. Okay. And I'm also going to convert this along the way. What's square root of x?
X to the 1.
Okay. Okay. So let's handle this problem first. What can I do with this x to try to get this first fraction cleaned up? So we can't do power rule yet. We can't do power rule yet. This x is still out of place. Where does this have to be? Numerator. So what happens if I move this up? I know it's tempting. You want to just look at that and do power rule, but it's connected to this denominator. We have to do our first step here. So how do I clean this up here? How can I merge these x's together? Common denominator. So 4 is same thing as what?
4, yeah. Or
8 over 2, right? So 4, I'm going to convert it to 8 over 2. And once that's 8 over 2, that's more helpful, right? 8 over 2 minus 1 over 2 is 7 over 2. Okay, so I know that's cleaned up. I can do power rule when I'm ready for it. Let's go to my second term here. That x also comes up, x to the negative 1/2. Okay, how would you combine these x's together?
Denominator, get 1/2.
Yeah. So there's a 1 sitting there. That 1 is really a 2 over 2. If I want to make it easier for me to combine those fractions together, 2 over 2 minus 1 over 2 is 1/2. And then this last term, which is going to be what? X to the negative 1/2. All right, so all that work is just to clean up. We haven't done any calculus yet. Now everything is set up and ready for us to apply power rule. Okay, subtract 1 from the exponent. 7 over 2 minus 2 over 2 is 5 over 2. One half minus 1, same thing as 1/2 minus 2 over 2. It's negative 1/2. Negative 1/2 minus 1 is same thing as negative 1/2 minus 2 over 2. This is 1x to the negative 1/2. I'm going to push that exponent, negative exponent, back down to the denominator. This x also showing a negative exponent. I'm going to push it down to the denominator. There's already a 2 in the denominator here, so I'm going to make the 2 and the x share the same space, denominator space. Okay, questions? Okay, let's do one final one here. Let's do number 9. What do you notice about number 9? What needs to be adjusted? Parentheses. So how would you handle the parentheses?
Factor and then distribute that.
Yeah, so FOIL, right? We're going to expand terms out, and then the x. The x comes last because we can't go from left to right because of order of operations. So I'm going to think of this as 2 minus 5x. Let's handle this piece first. So this is 4 minus 10x plus 25x squared. All right, you got negative 10x here. You got another negative 10x here, so that becomes negative 20x. Now distribute the x through. And now you're ready for power rule, right? No parentheses, no variables in the denominator, no radicals. Pretty easy, this one here. No fractional to deal with either. You can squeeze in one more if you guys are up for that. You guys okay at this point? Okay, so here, number 13, it says find the equation of a tangent line. So here are the steps we're going to take. We're going to find the, I did this out of order here. Let's find the derivative first, and then we can find the order pair using the order pairs already given to us. We can find the slope using f prime, and then we can put it in the point slope form. So let's find the derivative just like how we did the other problems. We see that this radical is needs to be adjusted, and it's also in the wrong place. So this is really what, 2 over x to the what power? Great force, and then we got to push it up to the top, right? Okay, so once we have our cleaned up version of our expression, we can do power rule. Bring the negative 3/4 down in front, subtract 1 from the exponent, match the common denominator, which is really negative 7/4. Do a little bit of cleanup, negative 6/4, which is negative 3/2. Bring that x down to the denominator. So now we're going to gather information. We're going to plug our x value into the derivative to get our slope. So we have our order pair, we have our slope. Let me collect that information. And then point slope form. The point's going to replace the x1 and y1, and then the slope m is going to replace that m there.
You guys want to